Okay, let's take a look at a few comparisons here of three different ways to describe how electrons may exist around an atom. Okay, we've dealt with electron configurations, and there's a couple of ways to show those. One is the quantum mechanical notation, and one's called a box diagram, also called an orbital diagram. And then the other one is comparing it to our Bohr model, which was sort of the more primitive version of this, but we're going to use all three of them and see if we can make some connections here. So the quantum mechanical notation, this is the electron configuration model you're used to. Okay, we dealt with in previous lessons before. So, for example, let's take a look at cobalt, which is number 27. Okay, that means cobalt has CO and it has 27 electrons we have to place. Okay, so the quantum mechanical notation for cobalt, we're going to start with 1s, and 1s can hold 2 electrons. So that little 2 means the electrons that are in that 1s sublevel. Then we go 2s. 2s can hold 2. 2p, 2p can hold 6, because it's a p subshell, it can hold more. Okay. After 2p comes 3s, it can hold 2. After 3s comes 3p, it can hold 6. Now take a look at where we're at. 2, 4, 6, plus 6 is 12, plus 6 is 18. So I've placed the first 18 electrons in their proper sublevels, but I got to get all the way up to 27. So 18 all the way to 27, I got 9 more to go. Okay? So after 3p comes 4s, and 4s can hold 2. And then after 4s comes 3d. Remember, this is that first place we see some overlap in the subshells and the main energy levels, and it kind of doesn't fill up in the order you think. Now a d can hold up to 10, but I don't have 10 electrons left to go. Okay, I got 2, 4, 6, 8. 8 plus 6 gives me 20. I got 7 more here. Okay, I got 7 more to go. So those final 7 are going to go in the 3D subshell. It's just not filled up. Okay, now that is the quantum mechanical notation, and it's the long version. The abbreviated version would go back to the previous noble gas. Okay, and in this case, the noble gas that comes before cobalt on the periodic table is argon. Argon is number 18. So argon is like writing the first 18 electrons. We're basically saying cobalt looks just like argon, but then it's got this extra. 4s2, 3d7. Okay, both of those are what we call quantum mechanical notation. Now, the box diagram or the orbital diagram, this looks we're going to write the abbreviated version so we can just see what the last subshell looks like. I'm going to write argon in brackets. Then I write 4s, but instead of writing the 2 electrons, I'm going to show them. Draw a box up here. Remember, an s subshell can hold 2 electrons. That means I'm going to draw 1 orbital. That's what we show with the box, is 1 orbital. And I draw an arrow going up and an arrow going down. And that represents 2 electrons in there that are spinning opposite directions. That's 4s2. Now we got 3d7. Okay, now look at d. D can hold up to 10 electrons. Okay, however, it only has 7 in there. It still has a capacity for 10, so I need to draw that capacity. I'm going to draw 5 orbitals. Okay, 1, 2, 3, 4, 5. 5 boxes means 5 orbitals. If each orbital can contain 2 electrons, that's my capacity of 10. Okay, and what I'm going to do here is I'm going to put these electrons in, but I'm going to put 1 in each orbital separate to start with. So electrons are going to repel, and they're going to go occupy separate orbitals if they can. Okay, if there's an open orbital, that's where they're going to go. But then once we have each orbital with 1 in there, a couple of them have to double up. That's 1, 2, 3, 4, 5 electrons, 6, 7. Okay? So we don't double up until we have to, but I have 3 open spots here where we could fit 3 more electrons if that subshell is going to fill up. This is called a box diagram or an orbital diagram. Okay, you're fairly familiar with these. Now let's compare this to the Bohr model. Okay? The Bohr model was the old model that had just the big rings, just the principal energy shells. So I'm going to start with, I got 27 protons in the nucleus. Okay. And I'm not going to worry about neutrons, but now I got 27 electrons around it. So I'm going to start drawing these energy shells. However, I need to know how many to draw. So let's kind of refresh our memory here. The big numbers, the coefficients, these represent the main energy shells. So when I look at this, I got a 1, 2, 3, 4. 4 is the highest number I go to. That means this is only going to occupy the first 4 rings. So I only need 4 shells. 1, 2, 3, 4. Okay? I'm going to draw 4 rings. Now, there's more than one way to draw this, but I don't really want to draw a bunch of dots for us to count. I'd rather total them up so you can see where things are at. So I'm going to look at this and go, okay, if I've already got the quantum mechanical, it tells me everything I need to know. Everything with a 1 in front of it represents the first shell. This is the only place I see a 1. So there's only 2 electrons in that first entire energy shell. So I'm going to write 2 electrons. Okay, just a little 2e to show there's 2 electrons somewhere in that shell. We go to the next one. This is a 2 and this is a 2. This is all part of the second shell. There's 2 electrons in that subshell and there's 6 in that one, but they're all part of the second ring. So I have 2 plus 6, that's a total of 8. So I'm going to write 8 electrons in the second shell. Now I go to the 3s. I got a 3 here, a 3 here, and a 3 here. All of those are part of the third energy ring. Okay? And this isn't drawn to scale. It would really be squished down towards the ends and they start to overlap, and I can't draw that very well, so I'm going to spread them out. But 3, 3, and 3, those are all part of the third shell. 2 plus 6 is 8, plus 7 is 15. So I have a total of 15 electrons in that third shell. And then I look to the fourth shell. That's the only place I see a 4. There's only 2 electrons there. Now if I add up 2 plus 2 plus 8 plus 15, I should get a total of 27. And the Bohr model is actually the primitive version. These big rings were separated into subshells as we started to understand this to a greater degree. So you've got your quantum mechanical notation, your box diagram, and your Bohr model. Typically speaking, in your homework, you're going to be asked to show all 3. So they give you one element, and you just need to show all 3, and you got to make sure that all 3 of these are telling the same story.